To my fellow Muslims, Mubarak Ramadan. In this episode, we have an example of a problem involving variable linear acceleration. We apply a simple integration to determine the instantaneous velocity of a particle. So just sit back, relax, watch, and learn. The problem is the acceleration of a particle is given by ax as a function of time equals negative 2.00 meter per second squared plus 3.00 meter per second cube times the time t. Question letter E, find the initial velocity v naught x such that the particle will have the same x coordinate at time equals 4.00 second as it had at time equals 0. Question letter B, what will be the velocity at time 4.00 seconds? We're given the horizontal acceleration as a function of time of the particle. So a of x is equal to a negative 2.00 meter per second squared plus 3.00 meter per second cube multiplied by time t. On our target variables, in part A, the initial velocity v sub naught x such that the particle will have the same coordinate at time equals 4.00 seconds as it had at time equals 0. And in part B, the instantaneous velocity v sub x at time t equals 4.00 seconds. The velocity vx of the particle at any time t is expressed as v naught x plus the integral of ax dt from 0 to time t, while the position x of the particle at any time t, right, is given in this expression. So x at any given time t is equal to x naught plus the integral of vx dt from 0 to time t. We use equation 1. We consider that the integral of t raised to the power n, except for n equals negative 1, is equal to 1 over quantity n plus 1 times t raised to the power n plus 1. So, with the given acceleration expressed as ax at any given time t equals quantity negative 2.00 meter per second squared plus 3.00 meter per second cube multiplied by time t, we find the equation for Vx as a function of time. All right, Vx at any given time is equal to V naught x minus quantity 2.00 meter per second squared times time t plus 1 half times 3.00 meter per second cube multiplied by t squared. To determine the equation for the position x as a function of time t, we use equation number 2. And earlier, we already had the equation for the x at any given time t. That is, Vx equals b naught x minus 2.00 meter per second squared times t plus 1 half 3.00 meter per second cubed and then multiplied by t squared. Hence, our equation for the position x is x equals x naught plus b naught x times t plus 1 half times negative 2.00 meter per second squared times t squared plus 1/6 multiplied by 3.00 meter per second cubed times t cubed. We got 1/6 because 1/2 here is still multiplied by 1/3, right? During the integration process. So, we can simplify this equation 3, okay, by letting the time t equals 4.00 seconds. All right. So at time equals 4.00 seconds, it was mentioned that the position x is just equal to the initial position x naught. So if we solve for b naught x in equation 3, we will have 0. Okay. Transposing x naught to the left side of the equation, we get 0 because x and x naught are equal. All right. So 0 is equated to b naught x times t minus 1.00 meter per second squared times t squared plus 1/6 of 3.00 is actually 0.500 meter per second cube and then multiplied by 3 cube. Isolating b naught x times t, we get 1.00 meter per second squared multiplied by 16.0 seconds squared, and then minus 0.500 meter per second cube multiplied by 64.0 second cube. So when we simplify by dividing the whole thing by the time t, which is 4.00 seconds, okay, we're able to simplify the value for v naught x, which will now be equal to 4.00 meter per second minus 8.00 meter per second, or that is v naught x equals negative 4.00 meter per second. So this is the initial velocity of the particle at time equals 0. And moving on to part B, okay, determining the velocity of the particle at time t equals 4.00 seconds. So we use this formula, Vx equals v naught x minus 2.00 meter per second squared multiplied by the time t plus 1 half times 3.00 meter per second cubed, then multiplied by the square of the time t. All right? So when we substitute the value of the time t, which is 4.00 seconds, we get Vx equals negative 4.00 meter per second. That's the computed value for V naught x, right? And then minus the product of 2.00 meter per second squared and the time t 4.00 second plus 1/2 of 3.00 meter per second cube, which is 1.50 meter per second cube, and multiplied by the square of the time, 4.00 seconds squared, which is 16.0 seconds squared. All right? So finally, doing our math, we arrive at the value of Vx, or the velocity of the particle at time equals 4.00 seconds. So Vx is equal to 12.0 meters per second. And that concludes our lesson for this topic. Mabuhay. Till the next episode. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.